Hello and welcome to another segment in further mathematics. Today we'll be talking on the topic sequence and series. Now, when we talk about sequence and series, a lot have to be discussed about this. But before we proceed on what we have to say now, can we just take a quick review of our previous lesson? Welcome back. Thank you. Now, our objective for today is sequence and series. Now, when you talk about sequence and series, we'll be looking into, in this context, we'll be looking into sequence and series, the AP, which is arithmetic progression, the arithmetic mean, and sum of terms of an AP. Now, sequence and series. Now, what is a sequence? A sequence is a pattern of numbers arranged in a particular order. Each of the number in the sequence is called a term. So that is to say, if I should write, if this is a sequence 2, 4, 6, 8, 10. So this is called 2 is a term, 4 is a term, 6 is a term, and 8 on its own is a term, and 5 is also a term. We don't usually say how many numbers do we have in this sequence. We use the word how many terms are there in the sequence. It is true that they are numbers, but when it comes to sequence, we call them term. So this is the first term, the second term, the third term, and numbers are usually called according to their position in the sequence. So if 2 comes before 4, let's say a sequence is being given to you and 2 appears first before 4, 6, 8, 10, you can't go into writing okay, we don't consider 2 being the least or 10 being the highest. It is being called according to how it is being written from the left to the right side. So this is our first term, this is our second term, this is our third term, this is the fourth term of the sequence, and this is the fifth term of the sequence. That's the explanation, and the terms are related to one another according to a well-defined rule. Now, the rule we are talking about is that there should be a difference between them. Like the sequence you're seeing in front of you now, you have 2, 4, 6, 8, 10. Now the rule of this sequence is that the preceding term surpasses the previous term with 2. So it is wrong to write a sequence as, this is not a sequence, 2, 7, 4, 100, 300, 4 million, 52, 73. It is not a sequence, because there should be a well-defined rule that is governing the existence of a particular sequence. So when writing a sequence, it should be an orderly arrangement of numbers that one can actually define either the difference or the ratio between the preceding term and the previous term of a sequence. Now, let's consider the sequence in front of us. We have 1, 4, 7, 10, and 13. Now, 1 is the first term of the sequence, just like what I explained here, because it appeared first. Despite the fact that it's the least among all, it's still the first term. If you remove 1 from here and place it at the middle, then 4 will take the position of the first term of the sequence. So, when you're talking about sequence, there should be an order, a well-stated rule that must not be altered in as much as the criteria of the sequence is being taken into consideration. So when you talk about the first term of the sequence, that is 1, 4 is the second term of the sequence, 7 is the third term of the sequence, 10 is the fourth term of the sequence, and 13 is the fourth term of the sequence. Now let me go into explaining the rule. Okay, let's write this sequence and see if we can actually deduce the rule that governs them. 1, 4, 7, 10, and 13. Now, if you watch between the sequence, it is usually the common difference between each of the term is plus 3. So, if you add 3 to 1, you get 4. You add 3 to 4, you get 7. You add 3 to 7, you're having 10. When you add 3 to 10, you're having 13. This 13. You're having 13. Now, if you now do 15, 72, 41, 100, the addition of this that have actually damaged this is no longer a sequence, because if a rule play to a particular point and happens to start deviating from the actual essence of how it's been, then it's no longer a sequence. A sequence must follow an orderly pattern for it to be termed a sequence. Now, if you add a sequence, addition of sequence to its last term or to a particular term that is needed, is called a series. Now, they said the sum of terms in a sequence is regarded a series. The series of the above sequence is, now when you talk about the series means addition of terms. When you have 1 plus 4 plus 7 plus 10 plus 13, which equals to 35. So the series talks more about the sum of terms of a given sequence. So you cannot have a series without having a sequence. A sequence must exist before you have a series, and the sum of terms of a sequence is what will give you a series. So sequence comes before a series. Now, each sequence has a well-defined rule that has been stated. You can call it the end term of the sequence, or you can call it most times you use the formula for finding the preceding terms of a particular sequence. But in sequence, we call it the end term. We call it the end term of the sequence. And when you talk about the end term of a sequence, you're trying to bring out the rule guiding that particular sequence, because I said something that for it to be a sequence, there should be a well-defined rule that governs the appearance or let's say the presence of the next term that will be in the sequence. And that rule is called, we most time use the word the end term, because remember we said each member of a sequence is being called a term, not end member. It's called an end term of the sequence. So for example, let's say we are having a sequence 5, 9, 13, 17 and 21. If I now ask you a question, what will be the 40th member of the sequence? If I should ask you now with an assumption, what do you think would be the 40th member of this sequence? What will you tell me? You don't need to come and start writing 5, 9, because from what you're seeing now, what they are doing now, they're just adding 4 here, plus 4, plus 4, plus 4. Okay, you start writing 5, 9, 13, 17, 21, 25. We are now adding 4, 25, 29, 33, 37, 41. When will you get to the 40th number? You discover that it is very, very straightforward. What if you're being asked now to get the 100th term or the 200th term of the sequence? So that is the essence of finding the end term of the sequence, because the end term will now serve as a guide for us into searching for any other term that we are looking for. Now let's use this in generating. Let's see what is similar between the numbers we have in front of us. Now the first term here is 5. The second one here, so we call it our T1. That's term 1. Now the second term here is 9. The third term here is our third term here is 13. Now if you watch, you see that the first term here is 5 plus 0. The second term here is 5 plus 4. The third term is 5 plus 8. Here we have 1721. That's T4 and T5. We have 5 plus 8. This term here is 5 plus okay, this is 5 plus 12. This is 5 plus 16, that's 21. 5 plus 16 continuously. Now look at what's going on in this sequence. The first term here is 5, which is constant, but look at what is going on in this other line. 0, 4, 8, that's they're adding multiples of 4. So we now have 5 plus, so this should be 4 times 0, 5 plus 4 times 1, which is 4, 5 plus 4 times 2, 5 plus 4 times 3, 5 plus 4 times 3 is 12, and 5 plus 4 times 4. Now this is what they are doing. But remember, when they were dealing with the first term, which is T1, what they had here was 0. Now when it came to T2, they are having 1. So T3, they are having this. So if they get to T40, they'll be having 439. I don't know if you get me. 5 plus 439. So at this point, you can generalize the formula by saying it is 5 plus 4. Since this is 0 for 1, so the first term is now 4 and n minus 1. So which is 5 plus 4n minus 4. So 5 minus 4 is equal to 5 minus 4 here is 1 plus 4n. Now this is the equation. This is our nth term, Tn, that can be used in solving anything. So if you apply this into this first term, you square the first term is 1 plus 4 times 1, which is equal to what? 5. And the second term now is 1 plus 4 times 2. 2 times 4, 8 plus 1, 9. You do that to the third term, 1 plus 4 times 3. Our third term is what? 13. So the nth term of this is, that's Tn, is equal to 1 plus 4n. So if you want to look for the number 100th term, you can just write T100 is equal to 1 plus 400, because 4 times n is what? Is 400. 4 times 100 is 400. So which is 401. That's the 100th term. That's what I'm trying to say now, that if you keep writing 5, 9, 13, 17, 21, 25, 29, 33, 37, 41, continuously, if we keep proceeding down and down and down and down, you discover that at the tail end of everything, when you get to the 100th term, what you'll be writing is 401. If you keep adding 4, 4, 4, 4, 4, before you get 401 should be the 100th term. Now let's solve this as our example 2. Example 2. Find the nth term of 3, 5, 7, 9 continuously. Now look at what's going on in this other one. Our T1 is equals to 3. Our T2 is equal to 5. Our T3 is equal to 7. And our T4 is equal to 9. Now I want us to just try something. Now with this, we know that this 3 is equal to 2 plus 1. 4 is equal to 5 is equal to 4 plus 1, and this is equal to 6 plus 1, and this is equal to 8 plus 1, like this. So with this, you can see that 1 is constant, but there is something changing here. Multiples of 2. We have 2, which is 2 times 1, 2 times 2, 2 times 3, 2 times 4. So this is 2 times 1 plus 1. This is 2 times 2 plus 2. This is 2 times 3 plus 3. This is 2 times 4 plus 4. So with this, we proceed again. Since we have 2 times 1 in the first term, T2, we have 2 times 2, so we can say it's 2n plus 1. So you now do 2n. If our n is 1 here 1, 2 times 1 is 2 plus 1. Like that. So our n term, our Tn will be equal to 2n plus 1. So if I should tell you now to find T100, all you need to do is 2 times 100 plus 1, which is 201. So the 100th term of this is 201. I would like to say a very big thank you for being part of today's lesson. But to refresh your memory on what we've just discussed, I would like you to test the test that will be appearing shortly in front of your screen. Do well to use the lesson notes on the platform for a better information on the topic we've discussed. Thank you.